Fourth grade lesson 11.1 is angles and fractional parts of a circle. Our essential question is, how can you relate angles and fractional parts of a circle? So we'll do an investigation here. And if you're needing the little tiles, I do have those in the classroom. You can just ask me for them. Place 1/12 piece on a circle and place the tip of the fraction piece on the center of the circle like that. Trace the fractional piece to create an angle. What parts of the fractional piece represent the rays of the angle, and where is the vertex of the angle? So just a real quick, if we had a fractional piece of 1/12, it would fit there. The rays, remember, are they stop on one side and they continue on and on the other side. And so this is the stopping point. So this is one ray, this is another ray, and the center of the circle is the vertex. And if I went ahead and went through and put those 1/12 pieces all the way around and traced them or filled them in, it would look like this. All right, that's how that would look with 1/12, 1/12. And if I were to count them up, you can probably guess how many 12s it takes to make one whole pizza. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Because 12/12 is a whole. So we shade the angle formed by 1/12 piece and label it 1/12. Place the 1/12 piece back on the shaded angle, turn it counterclockwise. Counterclockwise means the opposite direction that a clock goes. We know that a clock goes tick tock, tick tock, tick tock, tick tock in that direction. Opposite of that, counterclockwise, goes this way. Tock, tick, tock, tick, I guess is the sound of, I don't know what sound it would make. Anyway, trace the fraction pieces in its new position. How many 12s have you traced in all? And at this point, this question means we've traced one, like they said, and then we put it down and traced another. So at their point, they're asking this question. I've only traced two based on their direction, so I got a little ahead of us. Then they say turn the fraction piece counterclockwise again, this way, and trace it and label the total number of 12s. So I trace the next one, and now I have 3 12s. 3 12s right there. And then I keep doing that, 4 12s, 5 12s, all the way around, and I'm going to get, of course, oops, that's 6 12s, 12 12s. You say to continue until you reach the starting point, the shaded angle. How many times did you need to turn the 1/12 piece to make the full circle? 12 times. How many angles come together in the center of the circle? 12 angles. 12 12ths makes one whole circle. So on the next page, they say, compare the size of the angle formed by a 1/4 piece and the size of the angle formed by a 1/12 piece. So we have this 1/12 all the way around. Use a 1/4 piece or 1/4 piece and your model on page 441 to help. So I will take this 1/4 piece and I'm going to put it over this. How does that compare, this 1/4 of the circle or 1/4 of the circle? How does that compare to how many 12ths I took up? I took up 1, 2, 3 12ths, right? This amount is the same as over here, 1, 2, 3 12ths. So I wrote that as it covered 3 12ths. Describe the relationship between the size of the fraction piece, this piece, and the number of turns it takes to make a circle. So if I were to do, let's say I was going to do this amount. So we know if I did the size of the fraction piece was in 12ths, how many times did it take me to turn that 1/12 piece all the way around to make the full circle? It took me 12 12ths, right? What if I used this 1/4 piece? Let's try it. So here is the 1/4 already there. I'm going to turn this piece. Oopsie. Oh, now I'm making a mess of things. Stay there. There's the other 1/4. There's 3/4. And, oh, looky there, 4/4. Oopsie. It matched the denominator, right? Because it's making one whole, right? If we had thirds, it would take 3/3 to make the whole. So describe the relationship between the size of the fraction piece and the number of turns it takes to make a full circle. If the fraction piece is 4, then how many circles does it take to make the full circle? 4. If the fraction pieces were 12, it took 12 to make the full circle. It takes the same amount as the fraction piece. I don't know if that's the best wording for that. You might be able to think of a better way to word that, but it takes, if it's the fractional piece is 4, it will take 4 of them to make that full circle. If the fractional piece is 12, it will take 12 of them to make that full circle. Relates to 4/4 being one whole, 12/12 being one whole. So that's the relationship there. So now let's make the connection to a clock and a circle and the fractional pieces. You can relate fractions and angles to the hands of a clock, and I know you guys aren't really used to using these types of clocks anymore, but this might help when you're faced with that. This knowledge might help that fall into place. Let the hands of the clock represent the rays of an angle, and each 5-minute mark represents 1/12 of a turn. So we have the 5-minute mark. This is 5 minutes, by the way, on a clock. Total of 60 minutes on a clock, right? The 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 represent the hours, or every 5 minutes. So every 5-minute mark is the 1/12 mark, right? So let's go ahead and put that fractional piece, 1/12, just like we did in the previous one. That's one of those 1/12 pieces. So if I have 1/12 here, 1/12 here, and 1/12 here, that's 3/12. 5, 10, 15 minutes has elapsed. 15 minutes is 3/12. The minute hand makes a 3/12 turn, which is, when you look at this circle and think of fractions, that is 1 out of 4 pieces, right? 1/4. And of course, if we reduce the fraction, that would be 1/4. So 1/4 turn clockwise, 1 out of 4. If I had 4 more of these, that would cover that up. 30 minutes elapse. You probably can see exactly where this is going as a fraction. If this is one whole and it's cut into 2 equal pieces, and 30 minutes covering one of those 2 equal pieces, 30 minutes elapse. The minute hand makes a 1/2 turn clockwise. And by the way, that is 1, 2, 3, 4, 5, 6 out of the 12, right? And by now you guys know 6 out of 12, that is 1/2. That's the equivalent of 1/2. 6 is half of 12. 45 minutes has elapsed. There's 15 minutes, 30 minutes, 45 minutes has elapsed. And when you look at that as a fraction, and I split that into 4 equal pieces, that is 1, 2, 3 out of those 4 equal pieces. That's 3/4 of an hour. And if I were looking at that as 12s, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 12s. 9 12s, 9 of the 12s. Oopsie, what happened? Okay, 9 of the 12. And reduce down, we would get 3/4. 3 divides into both of these. 3 divides into 3. 3 divides into 9 3 times, and 3 divides into 12 4 times. So 45 minutes is 3/4 of an hour. And as 60 minutes elapsed, the whole thing, that's 12/12, which you know is one whole. The minute hand makes a 1 turn clockwise, 1 full turn clockwise. So they're just making some relationship connections with what you know of circles and fractions. Let's do the Sharon show for the practice. The sorts of questions you're going to see. Tell what fraction of the circle the shaded angle represents. Okay, well, if my circle is split into 2 equal pieces and one of them is shaded, that angle is 1/2 of my circle. So still taking that fraction knowledge and applying it here. If my circle is shaded here, this is my angle. If I continued cutting that ray went down this way and this way. I have this cut into 4 equal pieces, and of those 4 equal pieces, one of the 4 is shaded. For question number 3, if I continued these rays out the opposite direction, I can see that I'm split into 1, 2, 3, 4 equal pieces. And of those 4 equal pieces, 3 out of the 4 are shaded. So 3/4 is what's represented, 3/4 of the circle. This one is, I could split it any way I want, but the whole thing is shaded, right? So 1, One whole, the whole thing is shaded. This angle this is the ray, and you can imagine the other ray laying on top of it. It's gone all the way around and met right back up again from the beginning. Okay, try this one. What fraction of this circle is shaded? Did you get 1 out of 2? 1/2? Okay, this one might be a little trickier. 6. What fraction of this is shaded? I can draw my continued lines like that. And you could see that I'm going to have more of those same side lines going out. Got to try and make that the same size as much as possible. It would be better if I had a piece that I could cut out the exact size of that piece and take it around. But you could kind of see that it looks like that 5 minutes on the clock, right? So it looks like if I had split that into 12 equal pieces, one of those pieces were shaded in. In this next part, it says tell whether the angle on the circle shows 1/4 or 1/4, 1/2, 3/4, or 1 full turn. So we're looking at the turn going whatever way the arrow says it's going. Is it 1/4? And I'm going to draw some pictures to help my brain with that. 1/4 would be like that amount. 1/2 would be that amount in either direction. 3/4 would be split into 4, and 3 of those 4 are covered. And then, of course, 1 whole is the whole thing is covered. Okay, with those images in our brains now, let's take a look. If I start here and I go this way by this much, how much of the circle did we cover? 1 out of 4. 1/4 is covered. If I started here and moved my hand all the way to here, how much of it was covered? How much of the circle was covered? Yeah, it looks like this here, doesn't it? Only opposite, but yeah, it covered 1/2 of the circle. And if I started, if I started here and moved all the way around to here, so that we're talking about this part is the part it went across, that is 3/4 of it that it covered. So you just have to kind of follow that arrow. And let's take a look at this one. Susan watched the game from 1 o'clock p.m. until 1:30 p.m. And they showed us 1 o'clock p.m. on the clock, where the little hand is pointed to the hour. That represents the hour of 1, and 0 minutes. If our minute hand is going straight up, that is 0 minutes. So 1 hour and 0 minutes. And it moved until 1:30 p.m. So remember, these are like minutes. These are minutes. These are in increments of 5, 5, 10, 15, 20, 25, 30. So the long hand transitions across 30 minutes and ends up down here. It's still 1 o'clock. It's 1 and 30 minutes, or 1 o'clock and half an hour. They say, describe the turn the minute hand made. It made a turn from here down to here, right? It was here and it made the turn down to here. So it made how much of a turn? A half turn. That's all they wanted for that. Let's look at one more. Malcolm drew this angle on the circle. Which of the following describes the angle? And it says mark all that apply. Okay, let's start with the 3/4 turn. Does that apply? He started here. He moved around the circle this way. If we were to shade that in, shade, 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 all the ground that it covered, that is, in fact, 3/4 turn. So yes, we had a 3/4 turn. Was it a 1/4 turn? No. That if it had gone this way, it would have been, but it didn't. The arrow signifies that it went that way, so not that. So clockwise and counterclockwise, this counter means opposite of clockwise. We know that a clock's hands move this direction, so that is considered clockwise. So we would need to see the arrow going this way. If it was clockwise, we'd see the arrows going that way. So it is not clockwise. It is the opposite of clockwise, the opposite way that a clock turns, counterclockwise. So hopefully that practice helped you understand what they're trying to help us see with the turns. And the reason they want us to see this fractional piece with the turns is they're about to start talking about the degrees of a circle. And so they want you to get comfortable with circles and the fractional pieces of them.